All right, guys, we're going to take a look at programming exercises. Let's see which ones we got here. 1, 2, 4, 6, and 7. I'm just going to take a look at them. Not like I'm going to do them all. Let's take a look at 6. All right. The German mathematician Gottfried Leibniz, like I can speak German, developed the following method to approximate the value of pi. I used to actually make this a programming assignment. 1 minus 1 over 3 plus 1 over 5 minus 1 over 7, and so on. Add those up, multiply by 4, and you get an approximation of pi, right? Write a program that allows the user to specify the number of iterations used in this approximation, and it displays a resulting value. All right. So I guess that's 1 iteration, that's 2 iterations, that's 3 iterations, that's 4. Let's check their example. 5 iterations. All right, let's see if we can get this going on. So how do we get these numbers here? 1, 3, 5, 7, and so on. Well, there's all sorts of ways we could do this, right? We could use a while loop, a range loop. We could count by 2s, right? 1 to 3, 3 to 5, 5 to 7. So a range statement would handle that. How would we know what the upper limit was? What's our formula for that going to be? 2 times the number of iterations minus 1, right? So if we want to just do 1 iteration, 2 times 1 minus 1 is 1. If we want 2 iterations, 2 times 4 minus 1 is 3. I think that'll do it. We don't even have to subtract the 1, really, right? Because the way the range statement works, it stops 1 before. So we could do something like this. Iterations is, let's see if we can get their 5 going on, right? See if we get the same answer for 5 that they do here. All right. I'm going to print this message out, right? But I'm not going to actually get the input. You can do that, right? And then for x in range, starting at 1, going up to iterations times 2, and go by 2 each time, right? Let's just print out x and make sure that those numbers look good. Yeah, 1, 3, 5, 7, 9. That ought to do it, right? So, and we need the ability to flip between positive and negative. Well, you can do that by keeping a counter and multiplying it by -1 each time, right? Because the first time it'll be +1, the second time it'll be -1, and so on. So I'm just going to call that sine, right? We're going to start it off as 1. So let's multiply sine times x just to make sure that it says 1 minus 3 plus 5, and so on, because that's what we want here, right? 1 minus 1 over 3 plus 1 over 5, and so on. So I just want to see it flip between positive and negative, but we have to multiply it by -1 each time, right? Sine times equals -1. Let's get that going, right? 1, -3, 5, -7, 9. All right, we're almost there, right? We just need to divide that by 1, right? 1 over all that, right? So the value to add is going to look a lot like that, right? Value equals 1 over, parentheses, sine times x. And we also need just a value, right, to start adding to accumulate. So I'm going to say pi is equal to 0 so that we can add the 1 and subtract the -1 over 3. So after we calculate our value of pi, we could just say pi plus equals rather than calculate value. All right. So pi plus equals that. We'll have to multiply it by 4 when the whole thing is over, right? Pi times equals 4 because that's part of the equation. And let's print it out. Just see if we get the right answer, right? 3.39 whatever. Is that what they got? It is indeed. Okay. So you'd want to clean it up and make the output look exactly like what they want, right? Let them type in some input, print this message, the approximate value of pi, and so on. But that's a good start for it, right? You ought to be able to do it based on that. Yeah, I think that'll do it. All right. Not going to finish it, obviously. I just did want to go and take a look at that. Let's take a look at the other ones. I'm not going to do this for every one of them. And I want to go peek. So the triangle is equilateral. The triangle is not equilateral. How do you check to see if something is an equilateral triangle? You just check to see if the three sides are equal, right? Enter the first side, 2. Enter the second side, 2. Enter the third side, 2, right? So if you have three variables, S1 is equal to 2, S2 is equal to 2, S3 is equal to 2, you just got to check them, right? If S1 equals S2, there's all sorts of ways you can do this, but here's one way. And S2 equals S3, right? That'd do it. Because if that's true, then it's equilateral. You don't even need to check S1 and S3, because if S1 is equal to S2 and S2 is equal to 3, then some mathematical proof, whatever, some property says that S1 is equal to S3. And you just do that. Of course, you'd have to ask for the input. If they're all equal, then print whatever you're supposed to print. It's equilateral, else print it's not equilateral. Just like that. All right. That one's not too rough. Let's go take a look at 3.2. All right, so recall from the Pythagorean theorem that a right triangle, the sum of one side equals the sum of the squares of the other two sides. All right, that's similar, except you're going to have to do some math, right? And you're going to have to make double sure that you check all possible, right? Because it could be that the third side, let's check their sample input. You can always check to see what they're testing for by clicking on the checklist and clicking run checks. Even if you haven't written the program, you can check to see what input they're going to use. Are they always going to make the hypotenuse the longer value of the third one? Let's go and take a look. Ooh, 0 out of 9 checks. All righty. 3, 4, and 5. 3, 5, and 4. Okay, so this time, right, they made side 2 the long one. So you just got to be careful, right? It's going to take more than one check to get it to work. So you'll need some elifs in there, right? So if S1 is equal to 3, and S2 is equal to 4, and S3 is equal to 5, we just need to check, right? If, and what's that formula again? Let's go and take a look. The square of side one side is equal to the sum of the squares of two sides. So if 3 to the, well, no, if S1 to the power of 2, right, is equal to S2 plus S3, wait, no, we have to sum those, right, like this, square them, right, S2 and S3, then it's good to go, right? Put your colon on there and say it's a right triangle. Print a message and then just use another elif, right? If S2, you know what, we don't even need the parentheses there. So if S2 star 2 is equal to, the other two added together, and then if S3 star is equal to the other added together, and then finally else, print that they're not, right? So you're just going to use some elifs, right? You can always do the practice ones too. Standard science experiment is to drop a ball and see how high it bounces. Once the bounciness of the ball has been determined, the ratio gives a bounciness index. For example, if a ball drops from a height of 15 feet and it bounces 6 feet high, that means it's got an index of 6, and so 16 feet from the bounce after one bounce. So let's see if I can annotate this. Can I get my tools, drawing tools coming up? What does this do? Nah, I need a way of drawing. Well, I know one way. Go away. All right. If I just take a screenshot, then I can draw on it. All right, so it starts here and it goes down. Actually, I wanted to use a pencil, right? But anyways, goes down and then back up, right? And then it's ready to start going down again. So they call that one bounce, I believe. So it went 10 to 6. Now, what if it had a bounce index of 5? So it was half each time, right? So it would go 10 to 5 in one bounce. And then 5 to 2.5 for the second bounce. Is that what I'm getting out of this? So we get 10 here. And then 2.5, excuse me, 5 plus 5 plus 2.5. Is that how I'm understanding it? So that would be 5 plus 5 is another 10, and then a 2.5. I think that's right. All right, so let's go see. Let's see their example and see if we can get it to work, something like that. I'm not going to write any code this time. I'm just making sure. All right, so if the ball were to continue bouncing, the distance would be 10 plus 6 plus 6 plus 3.6, right? Just like I said, 10 plus 5 plus 5 plus 2.5. So yeah, note that the distance traveled for each successive bounce is a distance plus 0.6 of the distance of the ball coming back up. Well, I don't even know if that really makes a help, but you could say for one bounce, it's 10 plus half that. And then it's 5 plus half of 5. And then it's going to be 2.5 plus half of 2.5. So you're going to have some kind of range statement involved. Where's idle? I just want to write some notes here, right? So you have to have some kind of statement here. I don't know, for range in X. I really shouldn't do all this. Why don't we just take some notes like this? For bounce 1, it would be 10 plus 5. How do you really get that plus 5? It's the last bounce times the bounce index, right? And so the total bounce is equal, if you started it off as 0, right? And then you say it's equal to 10 plus 5 after bounce 1, right? And then for bounce 2, it's equal to plus 5 plus 2.5. And then it's plus equals 2.5 plus 1.25 for bounce 3. So I hope you can see a pattern here, right? So if you set that as a variable called bounce height, and then you add half of bounce height to it, and then for the next iteration, you divide bounce height, or you multiply it times, you set it equal to that, 1/2 of what it was before, except that 1/2 is based on the index, right? Hopefully you can get that right. This is the height, and this is the height times about the index. And that's the last height times about index. And so you'd have to change those values, and then that's that times about bounce index again. And so on. You know what? I bet there's some kind of cool series you could do where you do x plus x squared plus x to the power of 3 or whatever, where x was the height in the index. If you were a math guru, you could probably set that up. I'm not good at programming though. All righty, so let's consider that done. I don't want to give you any more details than that. You got to do some of this yourself. I can't do it all. All right, let's go take a look at the next one. I think that was 3.4. We've looked at 3.6. Let's take a look at 3.7. Teachers in most districts are paid on a schedule that provides a salary based on their number of years of experience. A beginning teacher might get paid $30,000, and then they receive a 2% increase over the preceding value. Write a program that displays a salary schedule in tabular format. Starting salary, annual percentage increase, number of years. Each row in the schedule should contain the year, number, and the salary. How about showing us an example? All righty, you can do that. I know you can do that. But if you can't, if you need help, get stuck. Give you a quick example how I might do that, right? I'm not going to do it, right? But we're going to have some counter for x in range, you know, starting at 1 and going up to 11 if I wanted to repeat 10 times in a row. And let's make the second value get increased by something each time. I don't know. I'm just going to start a number at 0. And then each time I'm going to add x plus 1 over x to it, just for numbers to increase, right? Total plus equals x plus 1 over x. That's just an equation, right? It's not the right equation. I just want to see the numbers go up. All right. And then we need to provide our output. Now you can figure out how to print the year and the salary. I'll show you a short, no, I'm not going to bother. Okay, yeah, I will. If you want to print a row of dashes, I know I mentioned this in the past, but you can always print a row of dashes like this. How many dashes do I want? 13, for example. There, 13 times quote dash quote. I'll print 13 dashes. Okay, well, printed my dashes, but it didn't print the total, right? So I would need to print X. So F quote, curly brace X in curly brace. Put a tab there, put something there, I don't know, at least a space, right? And then the total, right? Let's watch it go. All right, there's it goes, but it's got too many decimal places. We don't want to see those. So we need a way of formatting it so that it looks better. I'm going to take a stab at formatting it, but it's possible I don't remember, right? Is it just like that? Does that mean 2 decimal places? And if I wanted to occupy a total of, you know, 1, 2, 3, 4, 5, 6, 7, 8 spaces, can I do it like that? Can I just say 8.2 or 8.2f? Is that going to do it? Let's find out. See if my memory serves. Yeah, just like that. And we probably want to limit like the first one so that it lines up in columns as well. So why not make that say :2, right? Just occupy 2 spaces, just like the other one occupies 8 spaces. All right, I know you can do the rest. If you get stuck, that's fine. No shame, just text me. All right. So that should get you a good start. Obviously, this isn't the right formula, but that's, you know, 9/10 of the problem. The 10th is, you know, asking for the output and printing the header nice and writing the correct calculation there, right? You can do that. All righty. If you get stuck, let me know. So I did talk a little bit about each one, gave you good hints. Hope that helps. And some of y'all are working on these and some aren't, so I wanted to provide some help, but if you don't need that help, that's totally cool.